I'm Anil Kumar, and here is a practice test question for you. You need to find equation of a tangent line using the concept of limits. The question here is, find the equation of tangent line to the graph of the function f of x equals to 1 over square root x and parallel to the line x plus 2y minus x equals to 0. So when you want to answer such a question, first you need to find the slope of the given line. Parallel line means same slope. So let's rearrange this part. So we get what? We get 2y equals to minus x plus 6. Divide by 2, we get y equals to minus half x plus 3, right? So slope of the line which you're looking for is indeed equals to minus half, right? So that is the slope. So the question becomes, find the equation of tangent line to the graph of f of x equals to 1 over square root x, and parallel to this line means with slope of minus half. Correct? Now we will use the first principle of tangents of limits to find the slope of the tangent line at any general point on the given function, right? So that is how we're going to solve it. So we say slope at any point x equals to a on the graph of the given function should be limit h approaches 0, f of a plus h minus f of a divided by h. Correct? Now a plus h means you have to replace x with a plus h. So once you do that, you get limit h approaches 0. F of a plus h, the function is 1 over square root x, so you get 1 over square root x plus h, minus f of a means I should have written a here, I'm sorry, a plus h, minus 1 over a over h, correct? So this is a for us. Now whenever you have square root, it's square root of a, yeah. So you're substituting x with a. So let's try to simplify it. So we get h approaches 0. So we'll take common denominator, cross multiply. So we get square root a minus square root of a plus h, right? Divided by square root of a plus h times square root of a, and everything divided by h, right? So that is what you get. Now remember, we could actually simplify this. Let me rewrite this as limit h approaches 0. So I could write this as square root of a minus square root of a plus h over h times square root a times square root a plus h, correct? That is what we have. Now to simplify any equation with radicals, what we should do? We should rationalize. Perfect. So limit h approaches 0. Let's rationalize this. Square root a minus square root of a plus h over all this, which is h times square root a times square root a plus h. Multiply and divide by conjugate of this, which is square root of a plus square root of a plus h divided by square root of a plus square root of a plus h. Now when you multiply the numerators, it's like a plus b times a minus b, so you get squares, difference of squares in the numerator. Do not expand the denominator. That's kind of a rule whenever we do like this, right? So we get limit h approaches 0. So the numerator is square of this, which is a, minus square of the other term, which is a plus h, divided by all this, which is h times square root of a times square root of a plus h times, let me put all this in brackets, square root of a plus square root of a plus h. Now once I open the bracket, what do I get in the numerator? As expected, minus h is what I get. Minus times plus h, okay? So that will cancel with this h, and that's the whole idea of rationalization. It helps us to simplify, correct? So that's all we have here. So once that cancels off, you can substitute h equals to 0 here and then find the limit of this function as x approaches a. So in that case, once I cancel this, I get minus 1 in the numerator. So I get square root a times square root a, right? Square root a times square root a. h is 0, and then here I get within brackets square root a plus square root a. Perfect. Now that gives you the slope, right? So square root a times square root a is a, and this is 2 times square root a, 1 minus 1 over, right? So let me just write this as minus 1 over. So I get a times 2 square root. Perfect. So that is what I get. Right? So this is the slope at any point. What do we need? So let me now see how to simplify this. We need a slope of minus half. So if I equate this to minus half, I can find the value of a. That is what we need, right? We are interested in a point on this graph where the tangent line has the same slope as that of this line, which is minus half, correct? So that's what we need, right? So let me simplify it further. So what we are trying to say now is that the slope of the line should be minus half, and we have, in general, the slope is minus 1 over 2 times a. So in general, the slope is minus 1 over 2 a to the power of 3 over 2. Do you see that? That is in the denominator. That should be equals to minus half, correct? So basically that gives you the value of a could be what? So the value of a is equals to, so if you find this out, so the value of a in this particular case has to be 1. Is it okay? Now, well, when you do this minus square root of this, you get that as the value, right? So only 1 will satisfy this particular equation. So that is what you get, right? So you could actually simplify it and say this is cube and then square root. So you say, right, so minus half a to the power of 3 over 2 equals to this. When you cross multiply, minus half cancels. So you have a to the power of 3 over 2 is equals to 1. So a is equals to 1, right? So that is the point, a equals to 1. Now when a is 1, in that case, what is the equation of tangent line? So at 1, the value of function will be f of 1 is equals to 1 over square root of 1, which is 1. Therefore the point is 1, 1. You get the idea? And the slope is minus half. Now let us say that the equation of the tangent line is y equals to mx plus b. So where y value for us is 1, x is 1, and m is minus half. So get 1 equals to minus half times 1 plus b. To find the value of b, we will take this on the right side. Is that okay? Yeah. So we get 1 plus half equals to b, or 3 over 2 is the value of b, right? So once the value of b is 3 over 2, we know what the equation should be, right? So the equation should be y equals to slope of minus half x and b of 3 over 2. So that is the equation of the tangent line. You get the idea, right? So that is our answer. I hope the steps are absolutely clear, right? So that is how you should be actually solving such questions. One important thing here is to also understand the domain. When we are checking the values of x, in that case, what we know here is that x value has to be greater than 0, right? It cannot be 0 also. It is in the denominator. So we are looking for a which is greater than 0. The only value which will satisfy this equation is when a is 1, correct? So that is how you should be actually solving such questions. I hope that helps. Thank you and all the best.